Hi guys, let's see how we can answer this question under rotational motion. So we have this horizontal beam supported by these four forces. So the question says find the magnitudes of this force and this force. Now in this question, we've not been given the distance between the forces. So let's just make an assumption. Let's just make an assumption that we can say, let's assume, let's assume that the distances or the lengths between each force is equal. Okay, so meaning that the distance from here to here, let's just call it L. From here to here, again, let's call it L. From here to here, let's call it L, because we need it when we'll be summing torque. If that's the case, now let's break down the question. So to start with, let's consider Newton's second law of motion, which says that force is a product of mass and acceleration. So in this case, to start with, we'll just focus on the y-axis. So in the y-axis, because we don't have forces in the x-axis, so you can say force is a product of mass and acceleration. So we're going to sum the forces, and these are forces in the y. So the summation of forces in the y is equal to 0. Because acceleration is 0, this system is not in motion, it's stationary. So how many forces do we have? We have 1, 2, 3, 4. So the forces which are going up will be positive. Hence we have a positive 100 plus a positive F2. The forces going down will be negative. So negative F1, negative 80. Everything is also 0. This becomes F2 minus F1. 100 minus 80 is 20. So if the 20 crosses the equal sign, this will be equals to negative 20. Let's call this equation 1. For the sake of reference, we'll come back to it. Now, the next part is we can choose a point of rotation. Now, this point of rotation must be at any point where you have a force. So let's choose our point of rotation to be right here. This is our point of rotation. So at this point of rotation, the torque that will be at this point will be 0, simply because the distance is 0. The distance from this to this is still 0. So at this point, the distance is 0. So we're going to consider torque here clockwise. We're going to consider torque here clockwise and torque here anti-clockwise. Because remember, since it's rotating about this point, then this is clockwise, this is clockwise, this is anti-clockwise. And this is determined by the direction of the forces. Now we know that for this system, the summation of torque is equals to 0. That is what will give us as the net torque. So at this point, we're going to say, what's the distance? Remember, torque is force times a perpendicular distance, of course. So what's the distance at this point? The distance is L multiplied by what's the force? The force is F1. Now remember, it's in this direction, hence we're going to consider a negative. So L distance times F1. Clockwise torque negative, anti-clockwise torque is positive. We come at this point. What's the distance? So we have two L's. From the point of rotation, we have L and L. So if we put them together, the distance is 2L. We are saying negative because it's also clockwise. So distance is 2L from there to here. Then the force is 80. At this point, it's a positive because now it's going in the clockwise direction. So now the distance here is 3L because we have L, L, L from the point of rotation. So 3L. The force at that point is F3. Everything is equal to 0. Okay. So at this point, we can say, let's get rid of these two. Let's push them to the other side of the equation. Or rather, before we do that, let's get rid of L. How do we get rid of L? We're going to divide L throughout. So divide by L, divide by L, divide by L, divide by L. So what do we get? This gives us a negative F1. This gives us the L cancels. So negative 160. If the 2 multiplies 80, this gives us positive 3f2. Not f3, is f2, sorry. f2. Everything is equals to 0. Okay. So left hand side, we'll have 3, just mark it here, we'll have 3f2 minus f1. This is equals to, the 160 can go that side, so it becomes a positive 160. So let's call this equation 2. So we just solve these two equations simultaneously, then we find the values of f1 and f2. So equation 1, we have f2 minus f1 is equals to negative 20. Equation 2, we have 3f2 minus f1 is equals to 160. Okay, so we can eliminate by subtraction. If we subtract here, we'll get a negative, or rather, yeah, negative 2f2. We subtract here, this will be eliminated, come this side. If we subtract these two, we'll get negative 180, like that. So now, from there, we can say negative 2f2 is equals to negative 180. So f2 is simply equals to 90 newtons. So we can find f1 by using any of the two equations. Let's use equation 1. So using equation 1, we know that f2 minus f1 is equals to negative 20. So f2, the 20 can come this side, positive. The f1 goes that side, positive as well. So we'll have f2 is 90 plus 20. This will give us f1. So the value of f1 is simply equals to 110 newtons. So these are the two forces. We have F1 and F2. Thank you very much. This is how we solve this question. In case you have a question, please feel free to drop it in the comments. Have a good day. So the question reads, a uniform beam weighs 200 newtons and holds a 450 load or object, which is this one here. So it has a weight of 450. As shown in the diagram, find the magnitude of the forces exerted by the beam. The forces we have F1 and F2. Those are the two forces that supports this beam. So how can we find the values of these two forces? Of course, we'll be using concepts of torque in this case because we're going to consider the object rotating in a certain direction. So to start with, since these forces are all in the y-axis or in the vertical, let's start by applying Newton's, which one? Let's apply Newton's second law of motion. We know that second law of motion states that force is a product of mass and acceleration. But in this case, this object is stationary, hence there is no motion. So we can say the summation of forces in the y-axis is equals to 0. Not mass times acceleration, but 0, simply because there's no motion. This object is stationary. It's being supported by two beams. So what are the forces acting in the y-axis? So the forces which are going up, we consider them to be positives. So we have F1 positive plus F2 positive as well. Then the forces which are going in the opposite direction, we consider them negative. So we have a negative 200 and a negative 450. Like that. So at this point now, what we can do is we can simply say F1 plus F2 is equals to, so both of, sorry, this is equals to 0. So both of these two forces can go to the other side of the equation and they give us a positive 650. Okay, let's just consider this to be equation number 1. I'll come back to it. Now let's go to our diagram. Let's discuss on the aspect of torque. The idea is we have to first choose a center of rotation, and the center of rotation must be at a point where an object can rotate about, and we can choose this point here, point A. So everything can rotate about this point. So now, how many forces are acting on this object, starting with the same one, but since the distance at this point will be 0, so this will just consider to be a 0. So the other forces acting on this, we have this force here, and this force here. Now remember, torque, we can say torque, the summation of torque on an object, in this case, summation of torque must be equals to 0. Now, rotational torque, we know that clockwise torque is negative and anti-clockwise torque is positive. So at each point, at this point, at this point, at this point, at every point where we have the force acting on the beam, we shall have torque acting on it. So let's start with this point here. So at this point, since A is the point of rotation, we're going to say this object can rotate about this point like this. Now, if you look at this type of rotation at this point, this is clockwise. Clockwise torque is negative. So what is the distance from the point of rotation? The distance is L over 2. So distance L over 2 multiplied by the negative force. Simply because it's going the clockwise direction and clockwise is negative. Let's come to this point. This point, it will also rotate this direction. Hence, it is clockwise since this is the rotation point. So since this is clockwise, what is the distance? The distance we have L over 2. L over 2, remember we need the distance from the point of rotation to the force. So we have L over 2 and L over 4. So we're adding L over 2 plus L over 4. Our LCM is 4, of course. And put it 2 there, 2 there. So we get 2L plus L, which will give us 3 over 4L, or 3L over 4. So the distance from this point to that point, we just add these two. Hence we get, remember we're summing the versus the torques. So we get 3L over 4 times the force. Now the force, which is the weight force in this case, the force is 450, but because it's in the clockwise direction, we're going to consider it negative 450. We have one more force, which is this one here. What is the distance for that force? Remember, the length of the beam is L, so that is L over 2 plus this, so the length of the beam is L. So to this point, the length is L. Add up this and this and this, we just get L. So that is L multiplied by F2. This is equal to 0. So why is this one positive? Because this one is going in the anti-clockwise direction, and in the anti-clockwise direction, torque is positive. So from this now, let's see how it simplifies. This becomes a negative 100 L, because we know that 200 over 2, we get 100. Then what we get here times 450. So here we get a negative 338 L. So if we multiply 3 over 4 times 450, you get 338 L plus L F2, everything is equal to 0. So we can get rid of L, because we haven't been given the value of L. So we can get rid of L by simply saying, let's divide everything by L. Divide, not 4, sorry, I'm pretty sorry. Divide everything by L. So if this divides by L, we just remain with negative 100. If this divides by L, we remain with 338. This we remain with plus F2. So these two negative values can cross the cosine, hence this is equal to 0. Hence F2, if these two negative values cross the cosine, we're going to get a 438 as the value of F2. So we have found the first force, which is F2, 438. How do we find the other force, F1? We go back to this equation that we had created here. So we can say F1, so we can say from here, F1 is equals to 650 minus F2. So F1 is equals to 650 minus 438. So the value of F1, let's see what we get, 650 minus 438. We get 212 newtons. So there we go. We have the two forces, F1 and F2. So understand the concept of torque. Clockwise, torque is negative, and anti-clockwise torque is positive. And you should make sure that the distance is from the point where the force is acting to the point where you have chosen as the point of rotation of that particular object. It can be a ladder. In this case, we're using a beam. The uniform 100 Newton pipe is used as a lever where must the fulcrum be placed if a 500 Newton weight is on one end to balance the 200 weight, which is on the other end. So the idea is we've just been given x and L minus x, of which L is the length of this particular pipe. So what I want to do is this. First of all, we're going to choose a point that we can consider the point of rotation if this was to be rotated. So the point that we can choose, let's choose here where we have the support, because remember we don't have the reaction force. We're going to look for it, so we don't have the reaction force. So before we find the reaction force, let's use this same point as the point of rotation, so that at this point the torque at this point will be 0, because the distance will be 0 times this force. Remember, torque is force times the perpendicular distance. So if that's the case, this is what we're going to have. We're going to say, since we have 3 forces, 1, 2, 3, or let's consider them 4 forces. We have 4 forces, 1, 2, 3, 4. But this force that we have here will produce a 0 torque, simply because this force is at the point where we have chosen to be the point of rotation. Hence, the distance will be 0 meters. So, if that's the case, let's also consider which one is negative, which one is positive, depending on the direction. And when we talk about direction, in this case, we're talking about clockwise and anti-clockwise direction. If this is our point of rotation, this force that you see here will be rotating in the clockwise direction. This force that you see here will be rotating in the anti-clockwise direction, about the point of rotation. Then this force here, the 200, will be rotating in the anti-clockwise direction as well. Torque, negative, is associated with the clockwise. Then positive torque is anti-clockwise. So let's go ahead and say the net torque. So net torque is equals to 0. Why? Because this object is not moving, hence the net torque, the torque clockwise, torque anti-clockwise will be equals to 0. That's the case. So if that's the case, let's proceed. What we're going to have in this case will simply be, we can start by saying, let's start with the anti-clockwise torque. Let's start with this one here. Remember, point of rotation is this one here. So what is the force? The force is 200. Before you do that, let's say torque is equals to force multiplied by the perpendicular distance, like that. So point of rotation, we have this force here, we have torque. This torque is anti-clockwise, hence we can say 200 multiplied by, what's the distance from this point to the point of rotation? The distance is x. So 200x plus, we have this one as well. Now, this one is also going in the anti-clockwise direction, hence it is also positive. If that's the case, what is the distance from here to here? That's what we want. So the distance from here to here, we can simply say this distance is x minus L over 2. Because from here to here, it's L over 2, but from there to there, it is x. So we'll say x minus L over 2, then we have this expression here. So the force is 100. The distance is simply x minus L over 2, like that. From there now, let's go ahead and find the torque at this point. Remember, the torque here is 0, won't even write it. At this point, it's in the clockwise direction, hence it's a negative. The force is 500, and the distance from the point of rotation is L minus x. So we can say this multiplied by L minus x. Remember, net torque is equals to 0. Okay, so if that's the case, let's see how we can simplify everything that we have. So to start with, we can say, let's expand here, and we can also expand there as well. So this is what I want to do. First of all, we can say expanding will give us 200x plus 100x. So 100 times over 2 will simply be half of 100 is 50. So 50L minus 500L. So 500 times x will become a positive 500x. Everything is equals to 0. Let's group like terms. So on the left-hand side, we want to put everything which has x. On the right-hand side, we'll take the L. So left-hand side, 100, 200, 100, and 500 will give us 800x. This is equals to 50, 500 goes to the other side. That is 550L. We want an expression for x. So we're going to say x is equals to 550L divided by 800. So that's how to get. So 550 divided by 800, we simply get 0.69. So x is equals to 0.69L. Now, let us understand what the question is asking. The question says, where must the fulcrum be placed if the 500 Newton weight at one end is to balance the weight on the other end? So for this to be balanced, we have to place, or rather the fulcrum must be the distance x, meaning that all we need is the value of L. So if L is 12 meters, then we simply say 12 meters times 0.69, then that is the position where we have to place the fulcrum. So in other words, we're just looking for an expression for x. Okay. So now that we have that, the second part of the question says, what is the reaction force exerted by the support on the pipe? The reaction force is this one here. So for this reaction force, we're not going to use the concept of torque. Rather, we're going to use Newton's second law of motion. So according to Newton's second law of motion, it states that force is a product of mass and acceleration. I believe we all know that. So Newton's second law states that force is a product of mass and acceleration. And we have forces in the y-axis, no forces in the x. So since we have more than one force, we can say we are summing the forces, taking the force pointing upwards to be positive. Okay, so if that's what we have, every force going up is positive, every force going down is negative. So we're going to say the force going up is the reaction force. So Fr, the reaction force, positive. Force going down, we have 200, negative. Another force going down, we have 100, negative. Another force going down, we have 500, negative. All this is equal to 0. Why? There is no acceleration, this thing is not moving, hence acceleration is 0. This will give us the reaction force, Fr, minus, if we add all these, we get 800. This is equals to 0. Hence, the reaction force is simply equals to positive 800 newtons. So there we have it. That's how we calculate the reaction force. Let's see how we can solve this ladder problem on torque and rotational motion. So the question reads, ladder leans against a smooth wall. The ladder weighs 200 newtons and its center of gravity is 0.4 L from the base. This is the base. And L is, of course, the ladder's length. So find the friction force as well as the coefficient of static friction. So to start with, we're going to consider torque. Remember, torque is simply force times our distance, and this distance must be, of course, perpendicular to whatever you have been given. So first of all, we'll have to choose a center of rotation, or we can call it a fulcrum. So a center of rotation that we can choose, let's choose this point that we have here. So if this is our center of rotation, now understand one thing about center of rotation. If you have chosen this as your center of rotation, it means that whatever force is acting on that point, the torque will be 0, because the distance is 0, because that is where the center of rotation is, and that is where the forces are acting on. So the torque at this point is 0. So what we need to do is we need to find the torque at this point, where we have the center of gravity, and we've been told that the center of gravity is 200. So let's just put our 200 newtons here. Then we also have this force at this point. Now, this force, we know that this is the normal force. Now, understand that normal force is always acting on an object, which is on a surface or against the surface. In this case, we have this part here, hence we have the normal force, and this part here of the normal force. Then friction force, at this point we have it, but at this point we don't have it simply because the wall is smooth. In other words, it's frictionless. Okay, so let's start by considering torque and the perpendicular distance. If you look at what we have here, remember, we've chosen this point as our center of rotation. So if this point is our center of rotation, what is this distance in the horizontal? So we need this distance multiplied by this force. So we can say net torque, the summation of net torque is equals to 0, or net torque is equals to 0. So in this case, we're saying the torque at this point plus the torque at that point should be equals to 0, since this ladder is resting against the wall. So to start with, like we said, we have a force here. So at this point, we first also have to identify whether the direction is clockwise or anti-clockwise, and that is dependent on the center of rotation. So if this is our center of rotation, then this point here, where we have the gravitational or the center of gravity of the ladder, we can see that at this point, it will be rotating in the clockwise direction. Now, clockwise torque is negative. But at that point, we can see that because of the normal force, this will cause this ladder to be pulled in the other direction, which is the anti-clockwise. So anti-clockwise torque is positive. So this is what we're going to do. Starting with this force that we have here, we're going to say we need to find the force times this distance that we have here. So what is this distance here? Well, depending on which angle of interest you take, in this case, I'll just use this 40. If this is my triangle, my right angled triangle, and my angle of interest is 40, it means that this side is the opposite. Since this side is the opposite, then this will be, we're going to use sine. Remember, SOHCAHTOA, sine, we use opposite, we use sine, adjacent, we use cos. So if I chose this angle 50, then I would have taken this to be my adjacent, then I'll use cos. So either way, you still get the same answer. So I've decided to use 40, meaning that this is the opposite. So if this is the opposite, then what we're going to have is this distance will simply be 0.4L, the hypotenuse, sine the angle. So hypotenuse, sine. Now, what is the angle of interest? We're using 40. This is the distance that we have here from the center of gravity. Now, from the center of rotation, from the point of rotation. Then from there, now we can say that's the distance. We should multiply it by the force. The force in this case is 200 newtons. Now, since it's in the clockwise direction, we said negative torque is, clockwise torque is negative. Remember, torque is equals to force multiplied by distance. So we can just say force times x, of which the distance must be perpendicular. So in this case, the distance must be perpendicular to the force. That's the reason why we're using this distance and this force, because they're perpendicular to each other. So now, if that's the case, we have the torque which is acting at this point. Now we need the torque that is acting at that point. Remember, this point is in the clockwise direction if you take this as your point of rotation. So we're going to say now, what is the distance? So the distance in this case now is, we're going to take the distance from this point to that point. Remember, it is at this point where we have the center of rotation, or the point of rotation. So what is the distance from this point to this point? To start with, let's consider this to be a big right angled triangle. Then we're going to say this whole thing is L, because we've been told in the question to say L is the ladder's length. So this whole thing is L, meaning that the hypotenuse is L. So if the hypotenuse is L, then the angle I will use in this case, I will decide to use 50, meaning that whatever you have here is opposite to this 50. If you want, you can use 40 again, it's the same thing. So I'll use 50, meaning that the distance will simply be L sine 50. Now, what is the force? The force is N2, which is the normal force, the second normal force. All this is equal to 0 because I said net torque is equal to 0. I hope that makes sense. So the distance here is not L. L is this one here. So to find this distance, using SOHCAHTOA, we're saying this is L sine 50, then multiplied by the force which is acting at that point, which is, of course, N2. So this whole expression is just helping us to find the value of N2. So this is what we're going to do. So this which has a negative, let's push to the other side so that we get L sine 50. Now all this is multiplying with N2. Now this whole thing will go to the other side. So let's just multiply 200 by 0.4. We get 80. So 0.4, 200, we get 8. So all this will go to the other side, remember? So we're going to get positive 80 L sine 40. Remember 0.4, 280, the L, we have it there, sine 40, we have it there. So if that's the case, we can divide both sides by L, then we can clearly see that L will cancel out. So what do we remain with? We remain with the normal force 2 sine 50 is equals to 80 sine 40. So the normal force 2 is equals to 80 sine 40 divided by sine 50. So let's see what we get. So 80 sine 40 divided by sine 50. I'm getting 67. So the normal force 2 is simply 67 newtons. It's a force. Okay. So now that we have that, let's see how we can answer our question. Let's just do this. Okay. So remember, we're looking for the friction force as well as the coefficient of static friction. So if that's the case, we can go ahead and say, using Newton's second law of motion, it states that force is a product of mass times acceleration, like that. So now let's start with the x-axis. So let's say we are summing the forces in the x-axis. So you can say summation of the forces in the x-axis is equals to ma. Now, how many forces do we have in the x-axis? In the x-axis, we have this force and this force. Remember, this one is in the y-axis. So let's consider the one going to the right to positive, or that other one negative. It doesn't matter which one you take. So you can just say the one pointing to the right is a positive, hence friction force positive. The one pointing to the left is a negative, normal force, like that. All this is equal to 0. Why? There's no acceleration. This thing is not moving. So if that's the case, then we can say friction force is equals to N2. But remember, we have found N2, meaning that friction force is equals to 67 newtons. So we found the friction force. How can we find the coefficient of static friction? Well, to do that, we first have to obtain N1. So how can we find N1? To find N1, we're going to use the same Newton's second law, but in the y-axis. So Newton's second law of motion states that force is a product of mass and acceleration, but we're in the y-axis and we're summing the forces. So we're taking up to be positive, meaning that the force going up, this one here, N1, just demarcate. So N1 positive, the force going down, which is this one here, is negative 200. So this is equals to 0. Again, there is no acceleration, hence it's equals to 0. Meaning that N1 is equals to 200 newtons. So normal force 1, 200, normal force 2, 67, and friction force is 67. The second question says, find the coefficient of static friction. Now, coefficient of static friction, we know first of all that friction force is equals to the coefficient of static friction multiplied by the normal force. Now the question is which normal force? We can't use this normal force because on this normal force there was friction. So of course we're going to use this normal force here. So multiplied by N1 like that. So since we're finding coefficient of static friction, we can say mu sub S is equals to friction force divided by the normal force, meaning that this will give us friction force we have is 67, while the normal force is 200. So if we divide the two, we're going to get a coefficient of static friction which has the value 0.34. Now it's a coefficient, hence it has no units. So that's our answer, just like that. So let's answer this question under rotational motion, which involves a ladder. It's also known as the ladder problem. So this ladder of length L is resting on a smooth vertical wall. The mass of the ladder is m, and the coefficient of static friction between the ladder and the ground, which is this point here, is 0.4. Find the minimum angle at which the ladder does not slip. Okay, so what we want to do is this. We know that we're going to have a normal force at this point. So it's supposed to be perpendicular to the surface, of course. So we're going to have normal force in this direction. Let's just call this normal force 1. Since this at this point, we're looking at the point where it does not slip. So if it does not slip, meaning that it will slip in this direction, of course, hence it's going to have a friction force in this direction here. This is friction force. For this one, it's on a smooth vertical wall. Hence, this one doesn't have friction force. And the normal force, which is perpendicular to the surface, will be pointing in this direction. Let's call this N2. Okay. So now that we have that, let's consider the length. Remember, we've been given theta here. So if this is theta and this is our length L, then let's follow it in terms of a right angle triangle. So if this is our right angle triangle like this, then we know that this will be L in the Y, and this is L in the X, like that. Now, according to SOHCAHTOA, we know that whatever is opposite will be the sign. So this will be L, the hypotenuse, sine theta. And this that we have here, this will be L, the adjacent, cos theta, like that. So this is L in the Y, this is L in the X, then this is our L, the hypotenuse, with our angle theta being here. That said, let's talk about the rotational motion or rotational torque in this case. Now to do that, we need to choose a point where this system or the ladder can rotate about. So let's choose this point here. Let's call this point X. So this ladder is going to rotate about this point X. The idea is it's not necessarily rotating at X, but you have to choose a point of rotation such that if this object was to rotate, it's going to rotate at this point. So now that we have that, let's consider the perpendicular torque. We know that torque in the clockwise direction is negative and torque in the anti-clockwise direction is positive. So this is what we're going to do. Since this is our point of rotation, we're going to have torque here, where there's normal force, and torque here. Now, why do we have torque here? Because this is the center of gravity. And we know that at the center of gravity, we're going to have mg. So at this center of gravity, so let's do this. We're going to draw a vertical line like this. And on this vertical line, we have the weight force, or mg. Remember, since we have three forces acting on this object, 1, 2, 3, then we need to have 3 torques. But in this case, the torque at this point will be 0, simply because this is the point at which it will be rotating. Hence, the distance covered from this point to this point is the same 0. So the torque at this point, so we can say the torque at this point, remember, our point of rotation is x. This is our center of rotation. So from this point to that point, this length, we're not going to use the length L, but what we're going to use is the perpendicular length. Remember, this is the force. What we need is the perpendicular length. So the perpendicular length in this case will be Ly. We have to make sure that we balance up the force going in the anti-clockwise direction and the force going in the clockwise direction. So the force going in the clockwise direction is in the anti-clockwise direction. Let's start with anti-clockwise. It's this one. This is the force. So remember, torque is equals to force. You can say force multiplied by a certain distance, and this distance must be perpendicular, of course. If that's the case, we can say the torque at this point. So we're looking at the sum of torque since this thing is balanced. So the sum of the rotational motion of torque should be equals to 0, or the net torque should be equals to 0. So the torque at this point, let's start at this point. The torque at this point, remember, it's force times distance. So the torque at this point is the force N2. Now, what is the distance? Remember, the distance has to be the perpendicular distance. So we can't get the distance L. We're going to get the distance which is perpendicular. And that distance which is perpendicular is L sine theta. Now, this is anti-clockwise, hence it's positive. Now, this is clockwise, hence to be negative. So the force in this case, the force at this point is mg. So the force is mg. Then the perpendicular distance. Now the perpendicular distance we're going to consider is the distance from this point to here, where the force is acting. That's the perpendicular distance. Now, since this is the perpendicular distance, remember the whole distance there is L cos theta. So half of it, because this is the center of gravity, so half of it will be L cos theta divided by 2. And this is equals to 0. Why is it 0? Because the net torque is 0. The torque at this point is 0 because the distance is 0. So if that's the case, this is what we can do. We can push this to the other side. Hence we have N2 L sine theta is equals to positive mg L cos theta divided by 2. We'll multiply both sides by 2. Hence we'll get 2 N2 L sine theta is equals to mg L cos theta, like that. So at this point, we can see that L is common on both sides, so we can divide both sides by L. The L will cancel out, so 2n2 sine theta is equals to mg cos theta divided by L, hence L has cancelled out. The next thing we're going to do is we're going to divide both sides by cos, so that we form tan theta. So dividing both sides by cos, what do we get? We'll get 2n2 sine theta over cos is equals to mg. Because on this side, cos has divided, hence we just remain with mg. Now, from trigonometry, sine over cos is tan. Hence, what we have here is 2n2 tan theta is equals to mg. Okay. Let's call this equation 1. We'll come back to it. So now that we have equation 1, let's see how or what we can combine it with to see what we're going to get. So this was obtained, of course, by using the concept of torque. The net torque is equals to 0. So now what we're going to need to use is the forces in the x and in the y. So the summation of forces in the y-axis should be equals to 0, since there's no motion in the y. So how many forces do we have in the y-axis? In the y-axis, we have this force, which is going up, and this force, which is going down. So using, let's use Newton's second law of motion, which states that force is a product of mass and acceleration. Let's do this. Okay. So let me just quickly bring it here. We say Newton's second law of motion states that force is a product of mass times acceleration. Now, in the y-axis, there are two forces, this force and this force, mg and normal force 1. So we can say normal force is positive, it's going up, while mg is going down, and we can take it as a negative, mg. This is equal to 0. There's no acceleration, this thing is not moving. Hence, n1 is equals to mg. Let's call this equation 2. Now, from there, this is 1, this is 2. From there now, this is the y-axis. Let's sum the forces in the x. So summation of forces in the x is equals to mass times acceleration. How many forces do we have in the x? We have friction force as well as N2. So they're pointing in opposite directions, of course. So either one of them can be positive or negative. So we can say N2 is positive, the other one is negative. So friction is negative. This is equals to 0 again. There's no motion. This thing is stationary. So N2 is equals to friction force. But remember, friction force is given the formula mu times normal. So the friction force is at this point where the normal force is N1. So normal force 2 is equals to friction force is mu, coefficient of static friction, times the normal force at this point. Not that normal force because there it's a smooth surface, but at this point, which is N1. So this is our equation number 3. Okay. So we have these 3 equations. Let's see how we can combine them to get our desired result. Okay, so this is how we can combine them. Remember, N1 is equals to mg. So here, where there's mg, we're going to replace it with what? N1. So substituting equation 2 into equation 1, here where we have mg, we're going to substitute it with N1. So this equation becomes 2 to N2 tan theta is equals to, remember, we substituted this with N1 according to equation 2. Hope that makes sense. Then from there now, let's bring in equation 3, this equation here. So from this equation, we can say, let's substitute N2 with mu N1. Okay. What do we get? So let me bring it here. So we'll have 2, where there's N2, I'll substitute it with mu N1. Then we have tan theta. Everything is equals to N1, like that. So now that we have that, we can divide both sides by N1 so that you can cancel both sides. So N1 will cancel out if we divide both sides by N1. Hence we remain with 2 mu tan theta is equals to 1. Then, since we're looking for theta, we can say tan theta is equals to 1 over 2 mu, like that. Now, mu is the coefficient of static friction, and it was given in the question. Mu was given as 0.4. So, theta will be equals to the tan inverse of 1 divided by 2 times 0.4. And if we compute this, the value of theta is 51.3 degrees. Hence, the angle required so that this ladder does not slip is 51.3 degrees. So there we have it. I hope it makes sense. We're given a cube which has sides 5 centimeters. So let us draw a rough cube to look something like this. Okay, there's our cube. So this cube has a height of 5 centimeters. It has a width of 5 centimeters, and of course it will have a base of 5 centimeters as well. So each side has 5 centimeters, meaning that we can multiply all these 3 sides, LB times H, hence the volume will be given by LBH, hence volume will be equals to 5 times 5 times 5, which will give us 125 centimeters cubic. Okay, so now that we have that, we can say we have the volume, we have the mass. Let us find the density. So density, we know that density is given by its mass per unit volume. So mass per volume, like that. Or we can use the symbol for density, which is rho. So rho is equal to mass per unit volume. The mass in this case is 250. grams over the volume, which is 125 cubic centimeters, meaning that our density in this case will simply be 2 grams per cubic centimeter. Okay, let's see the question that follows. For this one, we've been given the mass and we've been given the volume. We want the density. Same thing. So we know that density is equals to the mass over the volume, like that. So the mass given in this case is 1,200 grams, and the volume is 800 cubic centimeters, like that. Hence, the density in this case, if you divide the two, so 1,200 divided by 800 is simply 1.5 grams per cubic centimeter. Okay, let's look at the other two questions. So the next question says, if the density of an object is 0.8 and its volume is 100, calculate its mass. So how can you find its mass? We know that density, according to the same formula, density is equals to the mass over volume, or mass per unit volume. So we can say density rho is equals to m over v. Since we're looking for mass, we can cross multiply. Hence, mass will be equals to density multiplied by volume. So the mass in this case will be equals to the density given is 0.8 grams per cubic centimeter multiplied by the volume, which is 1,000 cubic centimeters. So we can see that the units for volume will simply cancel out and remain with a gram. So 1,000 multiplied by 0.8, and we're getting 800. So the mass in this case will be 800 grams, which is the same as 0.8 kilograms. So that's our mass. Okay, so the last question now is how does the density of an object change if both the mass and the volume is doubled? So the idea here is we know that density is equals to mass over volume. Now what will happen if we double the mass and we double the volume? What will happen to the density? So the best way to do this is let's use values first so that you understand it. Let's say assuming that an object has a mass of maybe 20 and has a volume of 5, like that. So what will be our density in this case? We know that our density will be 4. Now let's double both volume and density. Sorry, volume and mass. So the density in this case will be, if we double the mass, we'll have 40. If we double the volume, we'll have 10. So 10 into 40 is still the same 4, like that. Remember, these are grams per cubic centimeters or kilograms per cubic meter. It depends with what you've been given. Let's do it one more time. So let's double what we have here. So density is equals to 80 over 20. We double mass, we double that, so that what we get here is simply 4 grams per cubic centimeter. So you see what we have. As we double both mass and density, what we're getting is the same value. So the best way to answer this question is that doubling the mass and the density and the volume will give us the same volume, because this is a direct proportion. So that's the best way. The question says, find the pressure due to the fluid at a depth of 76 centimeters rather, in still water as well as in still mercury. So to start with, we need to make sure that we convert the density into kilograms per cubic meters. So the density for water is for part A. Density for water, we just multiply this by 1,000, of course. The density for water will become 1,000 kgs per cubic meter. And then for mercury, if you multiply this by 1,000 again, we'll get the density for mercury as 13,600 kilograms per cubic meter. Okay. We know that pressure is given by the formula rho GH. So to find the pressure, we can say pressure is equals to rho GH, where rho is the density G is the acceleration due to gravity, and h is the height. So for water, we can say pressure is equals to the density for water given is 1000. Acceleration due to gravity, let's use 9.81. The height, we've been given the height in centimeters, so let's just use the height in meters, which is 0.76 if we divide by 100. So computing everything, the pressure in this case will be equals to 7,450 pascals. So we can write it in standard form, or as a kilopascal, we can have 7.5 kilopascal. So that's the pressure for the water. Let's look at the pressure for the mercury. Again, the procedure will just be the same. So pressure is equals to rho GH. So in this case, pressure is equals to rho, the density of mercury, we're using 13,600. Acceleration due to gravity is 9.81 meters per second squared, and the height, we said we use it in meters, which is 0.75, 0.76 rather, like that. Okay, so what does this give us? This gives us a value of 1.01 times 10 to the power 5 pascals. Now, since we know that 101,325 pascals is equivalent to 1 atm, of which this value that we have here is just 1.01 times 10 to the power 5 pascals, which is equals to the same 1 atm, or 1 atmospheric pressure. So this is what we have. If that's the case, then the value for pressure that we found, we can just say this is approximately 1 atm. Like that. So there we have it. That's how we answer this particular question. In hydraulic press, such as the one shown in the diagram below, the large piston, which is this one here, has a cross-sectional area of 200 cubic centimeters, and the small piston has a cross-sectional area of 5 square centimeters. So if the force of 250 is applied to a small piston, which is this one here, find the force F1, which is on the large piston. So let's break down what we have so that we understand it. We know that we have A1, which is area 1. Let's just call it area 1. So area 1, we have been given 200 square centimeters, and we also have been given A2, which is 5.0 square centimeters. We've been given, or we don't have F1, that's what we're looking for, the force on the large piston, but what we have is F2, the force on the small piston, which is 250 newtons. So according to Pascal's principle, pressure under the large piston is equals to pressure under the small piston. So we can write it as, so we can say pressure under large piston, all this is equals to pressure under small piston. Now this is, sorry, it's supposed to be piston. Okay, so this is Pascal's principle. So if this is the case, then in other words, what we're saying is that P1 is equals to P2. Now, before we go ahead, you have to know that pressure is given by the formula force over area. So pressure 1 or P1 will be given by F1, force over area. This is equals to force over area, like that. So if that's the case, since we're looking for F2, we're looking for F1, we're going to make F1 the subject of the formula. To do that, let's cross multiply. So if we cross multiply, we're going to have F1 times A2. This is equals to F2 times A1. If we divide both sides by A2, remember we're making F1 the subject, hence we're going to get F1 is equals to F2 times A1 divided by A2. Now, it's just a matter of doing the substitutions. So F2, force 2 is 250. Area 1, what is area 1? We're using 200. So 200 divided by area 2, which is 5.0. So all this simply reduces to, reduces to 10,000 newtons. Now remember, 10,000 newtons is just equivalent to a force of 10 kilonewtons. So there we have it. The force acting on this piston is simply 10,000. In a car lift used in a service station, compressed air exerts a force on a small piston that has a cross section of radius 5 centimeters. So the pressure is transmitted by a liquid to the piston that has a radius of 15 centimeters. So the first question says, what must be the force, what force must the compressed air exert to lift a car weighing 13,300 newtons? So we need to find the force that the compressed air exerts on the small piston in order to lift the car weighing this force of 13,300 newtons. So to do that, we're going to need, first of all, to find the pressure, we're going to need, to find the two pressures, we're going to need area. To find area, because remember, pressure is force over area. So to find area, we've been given radius. So since this is a circular cross-section, meaning that we can use the formula for area of the circle, of which we're going to use pi r squared. But before we do that, let's convert the radius from centimeters to meters. I think it will be better that way. So we can say, let's just demarcate here like this. So for part A, we can say we've been given radius. So let's call them R1 and R2. So R1, we've been given 5 centimeters. So this is just the same as 0.05 meters. We've also been given R2. So R2 is 15 centimeters, which is equivalent to 0.15 meters. So we have the radius R1 and R2. Now we can find the area A1 and A2. So we know that area, quite area 1 will be equals to pi R1 squared. So if we find the value of pi R1 squared, if we compute this, A1 will be 0.0078 7854 square meters. Again, here we need area 2, which will be given by pi R2 squared. So area 2, if we do the substitutions, we're going to get 0.07 0.068 58 square meters. Okay. So now that we have this, to find the force with relation to pressure, we are going to use the Pascal's principle. So according to Pascal's principle, it states that the pressure under a large piston is equals to the pressure under a small piston. So we can write it like this. Let's just do this. Okay, so according to the Pascal's principle, like I said, we can say pressure under large piston. So pressure under large piston, all this is equals to pressure under small piston. So pressure under small piston. Okay, so if that's the case, we're simply saying P1 is equals to P2. So P1 is equals to P2. Now we know that pressure is force over area, so this will give us F1 over A1. This is equals to F2 over A2. Since we're looking for the force one, remember, is the force exerted by the compressed air. So the idea is, the formula that we have here, F1 is the force exerted by the compressed air, while F2 is the weight of the car. A1 is the area of the small piston, while A2 is the area of the large piston. If you look at the two radius, you can see that that confirms the ratio of the small area and the big area. So from there, we can make F1 the subject of the formula. To do that, we're going to cross multiply. If we cross multiply, we obtain F1 times A2 is equals to F2 times A1. So F1 is equals to, let's have it as F2 times A1 divided by A2. We can divide everything by just the same thing. So F1 will be equals to F2. Remember, force 2 been given, it was 13,300. So we have 13,300 newtons. Then if we divide the two areas, A1 over A2, we're going to get 0.1111, just in there, it recarries. Okay, so the value of F1 or force 1 will be 1,477.8 approximately. So F1 is approximately 1.5 kilo newtons, like that. It's approximately 1.5 kilonewtons. So there we have it. Let's see how we can answer the second question, which says, what air pressure produces this force? So to find this, we're going to say, we know that pressure is equals to force over area, like that. Now, what force are we talking about? The question says, what air pressure produces this force? So the force we'll be using here is the force exerted by the compressed air. So we can say force exerted by compressed air. Force exerted by compressed air divided by area of the small piston. So divided by area of the small piston. Okay, so if that's the case, let's just do the substitutions. So pressure will be equals to, the force exerted by the compressed air is the force that we're just from finding, of which we found 1,477.8 divided by the area of the small piston, which was 0.007854, like that. So if we divide the two values, we simply get 1.8, or we can write it as, let's write it as 188,158.9, which is equivalent to 1.88 times 10 to the power 5. Now, since it's times 10 to the power 5, we can say that we can just have it as pressure. I think it's okay like that. Let's just have it as 1.9 times 10 to the power 5 pascals. So that's our pressure. Hence, the required air pressure to lift the car is 1.9 times 10 to the power 5 pascals. So there we have it. Thank you very much. In case you have a question, please feel free to ask in the comments. I'll be happy to respond. Have a good day.